Today's lesson, we're talking about Module 2, Lesson 2. And the title is Transformations. There are 3 properties. And so to start off, we want to talk about how could you map one of the shapes to the other. So I have kind of this little shooting star of a shape. And it repeats itself, and obviously it's the same size and it has all the same angles. So if I wanted to map, meaning I wanted to take that shape and put it on top of another, how could I do that? So if the shapes are the same, I would slide one towards the other, and I would do that using a vector. And that is called a basic rigid motion. Basic rigid motions are the transformation like a slide. So I just go from one point to another. It can be a reflection, just like when you look in the mirror, you hold the mirror up to something. I have a line of reflection that flips an image over itself. Or I have a rotation where I take a figure and I rotate it around 360 degrees. So in the case of my shooting star, I have a transformation, which is just a slide from one shape to the other. And I do that with a vector. A vector tells you the direction and how far you're going to slide your shape. So it tells me, should I go up, should I go down, and it also shows me kind of the distance that I would travel. And vectors also tell me where I'm going to start and where I'm going to end. So it has a terminating point. So on my shooting star, I can go from A to A prime and B to B prime, and that's going to help me to map that shape. Now we're going to watch a few quick video animations which show an example of a couple different kinds of transformations. Now, transformation is a slide along a vector. So as you watch the animations, I want you to number your paper 1, 2, 3, and 4 and include some descriptions on what you're seeing that makes the transformations different from one another. So our first transformation takes a shape and it slides it along a vector in a direction and of a certain distance. Our second transformation slides an entire plane, and so along with it you're sliding not only the vector but a point included on the plane. Our third example slides a plane with points and lines. So not only do I create the transformation of the points, but also the line. And each of those transformations are the same distance as the vector. And lastly, this slide shows an object, the sun, also partaking in the transformation. So remember, make sure that you're jotting down some notes to describe each of those examples. So the 3 basic properties of transformations are going to be 1, that a translation maps lines to lines, rays to rays, segments to segments, and angles to angles. What that means is that if a line is a certain distance and you do a translation, the resulting line should be the same distance. Same things with angles, segments. The second basic property is that it's going to preserve length of a segment, so we just discussed that. And the third is that it's going to preserve the measure of an angle. So whenever you perform a translation on a shape, on an angle, on a line, it's going to preserve its measurements, which is really helpful for checking to see if the transformation is actually working. But mainly we use transformations to copy various figures.